Good day, everyone. My name is Pelo Toibayale. I'm an undergraduate applied geology student from the Federal University of Technology, Akure. I'll be making a presentation on energy transition, hydrogen as an energy resource for future energy dynamics. So on the screen is the outline of my presentation. I'll be starting by giving a general overview of energy transition. Then I'll move to the current global energy landscape. Then I would speak on hydrogen as a promising energy resource. Then I would continue by speaking on the consideration and limitation of hydrogen for. Then the recent technological advancement, future prospects, and projections for hydrogen as a fuel and an energy resources. Then I would wrap up my presentation with a conclusion. So energy transition is also known as energy system transformation. So it involves a shift in our energy consumption pattern and supplies. So it's basically involves the shift from some energy sources to other energy sources. So this is paramount in addressing global concerns related to climate change and environmental sustainability. So there are several factors that drives energy transition. So the first I'll be speaking about is energy demand. So according to projections, there is an anticipated 50% surge in energy demand by year 2015. So this is driven by factors like urbanization, economic expansions and population growth, which is most prominent in emerging countries. So for reasons like these, there is an anticipated surge in energy demand, and which can be as high as 50% by the year 2050. So another factors that drives energy transition is sustainability. So sustainability is a very important concept that needs to be focused on. So the majority of the current global energy landscape is generated from non-renewable energy sources, so which is prominently fossil fuel. And with continuous exploitation, so these resources tend to run out. So there is a need for the world to move towards generating energy from renewable and more sustainable sources. So the third factors that drives energy transition is the environment. So there is an increased pressure, there is an increased advocacy for cleaner energy sources. There are initiatives being taken by the global government, industries to move from the current energy sources to cleaner and more environmentally friendly energy sources, so which is mostly renewables. And the transition in is very crucial towards mitigating the emission of greenhouse gases. So this would foster a healthier living environment. And we know that the emission of greenhouse gases is very detrimental to our home Earth. So the next thing I'll speak about is the current energy landscape. So in the global energy landscape currently, the world is shifting towards cleaner and more affordable and sustainable sources, which is driven basically by environmental concerns. And the global government and industries worldwide are investing in renewable projects and implementing policies to reduce carbon emissions and greenhouse gases in general. So there is advancements in global energy storage technologies to enhance reliability and integration of intermittent renewables into grid. So on the screen is the different types of energy sources and their advantages and disadvantages. So on the top of the list, we have petroleum. So it is run by low-cost infrastructures, and the technology matured, and of course it has been used since the inception of the second industrial revolution. However, the use of petroleum products as an energy source comes with huge environmental burden, and some of which includes climate change and oil spillage, which can be very catastrophic and disastrous to our environment. And also we have natural gas. It is abundant domestically. It emits low greenhouse gases, but however, some of its disadvantage is that methane leak can be very environmentally polluting, and also fracturing and seismic activities, which are very essential in exploration of natural gas, can be very environmentally unfriendly. And also we have the nuclear energy source, which also emits low greenhouse gases, but its waste management and accidents can be very catastrophic. And this is a very big thing to consider. And this is a very big weakness of a nuclear energy sources. So we also have hydropower, geothermal, solar, and wind. So all of which are clean fuel and which all emit low greenhouse gases. However, due to factors like droughts and environmental and seasonal fluctuation regions, so this energy source can be somewhat unavailable, and or there is a kind of fluctuation depending on season and other factors. So they are not really and so reliable. So moving next, so I would be then we have hydrogen 4 as a potential energy resource for future energy dynamics. So hydrogen 4 is a zero emission fuel that can be produced from a variety of sources, some of which includes water, fossil fuel, and even renewable energy sources like wind, solar. So hydrogen is a fuel that finds application in diverse and vast areas. So it's a very versatile fuel, and also it's very clean. And considering what hydrogen is made from, water, so it can be made from water and renewable energy. So hydrogen is sustainable, so which meets all the criteria and the demands for an energy from an energy source which can be used, which can be a potential, which makes hydrogen a potential energy resource for the future energy dynamics. So moving forward, we have the several types of hydrogen, but majorly we have 3 types of hydrogen 4. So we have the gray hydrogen, the blue hydrogen, and also the green hydrogen. So the green hydrogen. So the green hydrogen is also called the renewable hydrogen. So it is the most environmentally friendly form of hydrogen fuel, and it is generated from the electrolysis of water. So the process involves breaking water into its constituent elements of hydrogen and oxygen. So in the process of generating green hydrogen, so there is no emission of greenhouse gases. So for this reason, this green hydrogen is called green. So because it is very environmentally friendly, renewable, and also sustainable. So it ticks all the boxes for energy resources that can be considered for the future energy dynamics. So moving forward, is the generation of blue hydrogen. So blue hydrogen is generated from steam methane reforming. So it is generated from natural gases. It involves reacting natural gases with high temperature steam. So in this process, natural gases is broken into its constituent elements of hydrogen and carbon. However, in the production of blue hydrogen, there is the emission of carbon dioxide. However, the carbon dioxide are captured and stored, so which reduces their environmental impact, which when compared to the standard natural gas production. So next, the third type of hydrogen fuel. So it's generation of gray hydrogen. So gray hydrogen is also made from steam methane reforming. So it involves reacting natural gas and iron at high temperatures. So, but unfortunately, in the production of gray hydrogen, carbon dioxides are emitted, since the gray hydrogen are made from fossil fuel. So the resulting CO2 are released into the atmosphere, and this contributes to greenhouse gases emission. So this makes gray hydrogen a less environmental friendly form of hydrogen. So when compared to the gray and the blue hydrogen. So applications of hydrogen. So hydrogen finds application in diverse areas and industries. So from the electronics to residential to automobiles to heavy vehicles to commercial buildings to marine to power plants and aerospace. So on the screen is a schematic diagram of the projected consumption of hydrogen by different areas of application by the year 2030. So going into details of the application of hydrogen in different industry. So we have the application of hydrogen in the aerospace industry. So hydrogen, when combined with oxygen, can be used as propellant in space vessels and ships. So it can be used as a fuel for powering different aircraft and space aviation vehicles. So and this shows its significance of hydrogen in space aerospace endeavors. So moving forward, hydrogen can also be it finds application in transportation. So hydrogen can be utilized in public and private transportation, and this showcase it showcases its potential as a clean and flexible energy carrier. So the popular automobile brands like Toyota, Honda, and Hawaii have been making vehicles that are powered by hydrogen fuels. And so they have been making a lot of them, and there is a lot of innovations going on in the automobile world, and like they have been a current trend in the adoption of hydrogen as a fuel, especially in the automobile world, in both personal and public transportation. So the third application of hydrogen fuel is in the electricity generation. So hydrogen can also be used to generate power. So when hydrogen reacts with oxygen across an electrochemical cell, so it can be used to generate electricity. So the generation of electricity, it comes along with the production of water and a small amount of it. So in the use of hydrogen to generate electricity, so there is no emission of greenhouse gases, and this makes it very it gives it a very huge potential to be adopted as the major power generation. And so it emits no greenhouse gases when it is used to generate electricity. So moving forward, it finds application in various global logistical activities. So, and this shows its importance in global supply chain and transportation as well. So next is the advantages of hydrogen. So hydrogen has a lot of advantages over the current the major energy source currently utilized in the world. So the first I will be speaking on is the that hydrogen can be produced without a carbon footprint. So, and this has been explained in the generation of green hydrogen. No greenhouse gases are emitted in the generation of green hydrogen, and also in the blue hydrogen, the carbon dioxide generated are stored using advanced carbon capture, utilization, and storage technique. And also hydrogen can be transported over long distances, and also it has high energy density when compressed, and this is best exemplified in personal automobile vehicles. So it takes a very longer refueling time than the normal conventional vehicles that are powered by fossil fuel and other. So hydrogen powered vehicles takes a very longer refueling time when compared with other vehicles powered by fossil fuel and other sources. So hydrogen produces clean power and fuel. So when hydrogen is used to generate electricity, there is no emission of greenhouse gases, and it is environmentally friendly. And moving forward, so hydrogen is versatile as an energy vector with wide application. So hydrogen finds application in diverse industries and fields. So it makes it a potential energy resource for the future. And with increasing technological advancements, it will find application in more and more industries. So the next thing is the safety consideration. So the safety consideration for hydrogen fuel is similar to that of the natural gas and the petroleum. So there is no need for sophisticated precautions in the safety consideration. So moving next, I will be speaking on the limitation of hydrogen. So having talked about the strengths of hydrogen, the advantages, the applications of hydrogen. So it comes with some limitations as well. So, and the first of it is the cost. So currently, hydrogen is more expensive to produce and transport than other fuels like gasoline and diesel. And this is due to the fact that the world, it's an evolving energy resource. So there is there is little technological advancement in hydrogen. But I believe that with increasing technological advancement, the problem of course can easily be overcome. So the next thing is the problem of production. Most hydrogen is currently produced from fossil fuel, which releases greenhouse gases into the atmosphere. So this is also a limitation because the production of gray hydrogen also contributes to greenhouse gases. So I believe with the innovations in green hydrogen, I believe there is a tendency for the world to move towards the production of green hydrogen, which is the most environmentally friendly and it emits no greenhouse gases. So storage. So hydrogen is a very light gas, so it takes a lot of energy to compress it to the density that can be suitable for storage. So also this can be overcome with increasing technological advancement. So we have safety. Hydrogen is highly flammable and it requires to be handled with utmost care and consideration. So the last thing is the infrastructure. We know hydrogen is a evolving energy resources, so there are little infrastructure that can facilitate the use of hydrogen as an energy resource. So and with I believe with wide and increasing acceptance of hydrogen as an energy resource, this can also be overcome. So recent technological advancements in hydrogen and hydrogen fuel and hydrogen technologies. So we have the storage. So and going back, so I spoke about storage as one of the limitations of hydrogen fuel. So hydrogen storage challenges are addressed by carrier formed through chemical reactions. And so there is a lot of work going on globally to overcome the problems of storage with regards to hydrogen as a fuel. So Canadian startup like H2 it employs metallic alloys for efficient and safe hydrogen storage with higher density. And this is a very good progress in overcoming the problem of storage in adoption of hydrogen as a fuel. So distribution. So we have witnessed startups like New Zealand's Eringa Energy. So they are establishing a network of over 100 hydrogen refueling stations by the year 30, targeting heavy vehicles and strategic locating generation units for efficiency. And I think this is also a progress in the distribution of hydrogen, and it can also improve the acceptance of hydrogen as a fuel source for both commercial and personal utilization. So the storage and production of hydrogen. So startups like Beyond Screw offers oil-free compressor, and Y Cyrus develop metahydrate compressors. So all of these innovations, it enhances hydrogen production and storage. So we know that efficient hydrogen storage is crucial. So I think this is also a good advancement in the world of hydrogen technologies. So moving next is the global initiative and policies. So the programs and the initiatives and policies that is currently being implemented by the world government and the industries to foster the adoption of hydrogen as a fuel source. So there are a lot of programs currently being a lot of policies and programs currently being put in place by the world governments and the industries to increase the acceptance of hydrogen as a fuel source. So one of such is the International Energy Agency's decarbonization pillars. So it emphasizes energy efficiency, behavioral changes, and also it recognizes hydrogen as a fundamental pillar for decarbonizing the global energy system. So, and also the U.S. Department of Energy's hydrogen program So it supports research, development, and deployment of hydrogen technologies, including hydrogen-powered automobiles. And these has been these are some of the initiatives and policies implemented by governments across the globe to foster the use of hydrogen and to promote the use of hydrogen as a fuel source. So moving next is the future hydrogen market trends and production. So over the years, so from the year 2022, there has been a significant growth in the hydrogen market, and also by the year 2030, there is an anticipated 21.5% growth in hydrogen market, and this is a very optimistic and a very a way to go in hydrogen market trends and production. So in conclusion, I would say hydrogen fuels offers transformative potential for sustainable energy transition, and this is due to its versatility, high energy density, and the fact that hydrogen is a clean energy source. And also, so to maximize its benefits, so there is a need for the world to concentrate efforts in advancing its technological requirements, infrastructure development, and widespread adoption. So, and this can be done through investment in research, innovation, collaboration. So all of this can help to maximize the potential of hydrogen and ushering in a more sustainable and resilient energy future. So together we hold the power to revolutionize our energy dynamics and create a cleaner and greener world. Thank you.